choose the best project, and then I will briefly review what we did in this lecture and kind of focus a little bit towards the latter end to talk a little bit about possible topics for the midterm on Thursday. Okay, so let's get started with the best projects. And by the way, there is going to be like runner-ups. We have 4 runner-ups, and then we have 2 top-rated projects, the number 2 and the number 1. And the top 2 projects, every person gets a bar of Belgian chocolate, and they get a 20% bonus on their project, and every of the runner-up projects here gets a 10% bonus. So if you're on this list, you already have full marks plus at least 10%. So how this works is each TA nominates 4 to 5 of her or his projects. Every TA goes through all of their projects, and then we sit down for a 3-hour meeting with pizza and discuss all of your project, watch all of your videos, look at the project themselves, and then we decide which projects deserve extra credit, and then we nominate all of them. And once we have nominated all of those that have extra credit, we vote on the top 2 projects. And each TA cast a vote towards his favorite 2 projects, and it was a very unanimous decision for both number 1 and number 2 this time. So the result is we have a first and a second place. They get the chocolate and 120% of the points, and we have 4 runner-ups. And all of these projects will be listed on the Hall of Fame on the website for many years to come. Okay, so in no particular order, and when I mention your project, if you're here, please stand up and say your name and briefly say 1 word about your project maybe. IUCN Red List, Stark Loraisley and Jaden Wagstaff. Hey. What your project is about?
Oh, it's demonstration of Wirecast. I just displayed data for all of the endangered animals by country.
Okay, great. So let's look at the video.
IUCN Red List visualization. This visualization represents data collected on numerous animal species by the International Union for Conservation of Nature, IUCN. The purpose of the IUCN dataset and this visualization is to increase public awareness of the danger to survival currently facing many animals across the world. To interpret this data, we have utilized a stacked bar chart as the primary visualization tool. The chart displays all countries simultaneously, with each grouping of bars representing 1 country. A hover over tooltip is implemented to assist the user in identifying which country they are looking at. Clicking on the grouping will highlight it. Each bar within a grouping belongs to a category and/or subcategory defined by the IUCN and is color-coded accordingly. There are 4 main categories used in the IUCN dataset: extinct, red list, unthreatened, and data deficient. Bars in the chart are color-coded based upon subcategories. Users can look up the definitions and colors of these categories via the key. Definitions are included within expandable text that is derived from the IUCN's website. Please note that animals that fall within the data deficient category lack sufficient information to qualify into other categories. The key also serves as a means for users to sort the bars based upon categories, or change the values of the bars from absolute numbers to percentages. Users may also choose to view data only on mammals or amphibians. Details on selected countries are available via the Details tab, which swaps category definitions for statistics. Optionally, users may choose to toggle on and off the IUC-defined regions on the chart.
Demonstration of Wirecast.
country selection is handled in one of three ways. First, as shown previously, clicking on a group within the chart will highlight and select a country. Second, clicking on a country within the list provided will also select it. Optionally, using the filter above the list will help users quickly find a country of interest.
This is a demonstration of Wirecast.
Last, the provided map below allows users to click countries of their choice and compare regions. Selection from any of these means will highlight the user's choice in all three displays and add their selection to the details section. The final visualization is a country corresponding graph, which appears below the map. This graph features 7 axes representing different subsets of animals on the red list for that country. Each point is connected by a line and filled with red. Clicking on the graph will display details for that country. This concludes the demonstration for the red list visualization. Thank you for watching.
Okay. Yeah, we like this project because it was really very interactive and very well done, and you could really facet the data in many different ways.
Demonstration of Wirecast.
Okay, the next runner-up is IAEA reactors by Lucas Albright, Brittany Sands, and Brandon Kim.
Our project was about nuclear reactors in the United States and just like their history and their progress, their status, and just there's a lot of information about reactors. I don't know what to say.
Great, and all of you are now CS students, right?
Demonstration
We're
of
all nuclear
Wirecast.
engineers.
Yeah, so that makes coming to being on this list really especially hard. So let's look at the video.
Hello and welcome to the IAEA Reactor Group presentation for CS6630 visualization. Our project was focused on the nuclear reactor fleet trends in the United States. We want people to see how the nuclear power industry has grown and spread across the nation throughout the years. There was a steady growth in nuclear power until about the 90s, and it has since remained fairly stagnant. So although there has been an increase in the production of electricity, there has not been an equal or proportionate increase in the electricity produced by nuclear power. Most of the reactors in the US were deployed in the 70s and 80s, and only a handful have been deployed in the past decade. The map is the first visualization because it easily displays the approximate geographical locations and overall reactor fleet trends in the United States. All current and past reactors, no matter their status, are displayed on the map. As the user hovers over a specific reactor, a tooltip appears with reactor-specific information. The next video is an area map displaying the electricity generation trend in the United States from 1957 to 2015. There's a pie chart in the corner of the area graph that shows the percentage of nuclear electricity generation for the selected year. The next visualization is the U.S. reactor timeline, which shows the number of reactors in each year from 1957 to 2015. There are 3 views for this timeline. The reactor time information by timetable corresponds to the timeline. It displays every reactor in a selected year with all of the corresponding reactor-specific information. The 5th visualization is the reactor fleet by state graph. The graph stays static with data from 2015, displaying the number of reactors a state has ever had, no matter its operational status. The last visualization is the reactor information by state table that corresponds to the graph. It displays every reactor in the selected state with all of the corresponding reactor-specific information. The user can interact with the web page by first selecting a year in the U.S. reactor timeline. When the user clicks on a bar, the bar is highlighted orange, the map changes, and so do the other visualizations. The table updates as well with the list of reactors for that year. The user can also select a different data set for the timeline by using the drop-down bar, and the timeline below and table below will update. The bars and graph in the table color coordinate with blue, red, and black like the map does. The user can also interact with the reactor fleet by state graph by clicking on one of the bars. When a certain state is selected, it is highlighted and the table below is updated. The selected state is also highlighted orange on the map.
Okay, did you speed up this video to fit into the 2 minutes? Well.
I talked as quickly as I could and it wasn't enough.
No, but we like this project because it allowed you really to do a deep dive into the data using fairly standard but really well combined charts. Okay, well done. The next one is Theme Park Queue Times by Tyler Jones and Spencer Purves.
This is a demonstration of Wirecast.
When you go to a theme park, there's a big problem. You have to wait in line. In Disney World, Magic Kingdom's goal is that every person rides 6 rides while they're there in a single day, which is absolutely ridiculous when the park's open for 16 hours. And so we figured, well, we measured wait times over the summer. This is related to my research, and so we're showing people what the wait times are for each attractions at Disneyland, so you can figure out how to avoid lines.
This is a demonstration
The
of
purpose of our project is
Wirecast.
to visualize queue times for attractions at the Disneyland Resort. We can do this for Disneyland Park and California Adventure. On the map, there is a box and whisker plot aggregating the data for all of the attractions in these 2 parks, so that the 2 can be compared more easily. Each of these circles represents a different attraction. If you hover over one, a tooltip is displayed with current information about the ride, as well as an average wait for the given day. The selected day and the time of day can be controlled using the slider and selection bar below the map.
This is a demonstration of Wirecast.
By increasing the time later on in the day, the current wait moved from 0 up to 50 minutes, while the average wait stayed at 37. If you select these tokens, their borders turn black. They also populate the graph and table at right. If you hover over a selected token, it enlarges and highlights the graph and table for the appropriate attraction at right. You can also hover over the graph or the table to achieve the same results.
This
The table is also
demonstration
sortable
of
by clicking the
Wirecast.
column headings. You can have both ascending and descending. You can change the day for which data is displayed in the graph as well. Or you can display data over the course of a week. When you click the Compute Route button, the visualization will suggest a route through the park to the selected attractions that will minimize your queue time. The dotted line begins the park entrance and then visits each of the attractions in the order that it recommends. You can modify this plan dynamically
This is a
by selecting new
demonstration of
attractions
Wirecast.
or by deselecting old ones. Note that when you deselect an attraction, it is also removed from the table and graph.
Here we liked especially the custom visuals and the route planning feature. It was really nice. Okay, I think the next is the last of the runner-ups, which is Insights in European League Soccer Transfers by Gianni Lin and Ji Wu.
Our project is basically about the inside of European League soccer player transfer. And if you like soccer, you guys would love it.
Hello everyone, welcome to our project.
Demonstration of
Our
Wirecast.
project contains 2 perspectives, the player and the money. The money stands for how much has been spent on buying players, and the player stands for the number of players transferred between leagues or teams. There are 11 leagues. The column here stands for this league. If we click here, we can say the teams belongs to this league. Here is a year brush. We can choose either 1 year
Demonstration of
or
Wirecast.
multiple years. Let's have a look about the teams from England, the Manchester United and a team from Germany, FC Bayern. This chart stands for the relationship between leagues. See. And this chart stands for the transfer relationship between teams.
Demonstration
You can
of
say
Wirecast.
that the 2 teams are connected by these 2 teams. Let's have a click here. Here's the Real Madrid. It's come from step. You can see everything updated. And we can click no as we like. Everything updated. And this one is the transition tree of the year. Here's the league version, here's the team version. And we can click here. If we click here, every team belongs to this league will be selected.
Wirecast.
And we can click here. And the team will be chosen. Here is the payer version. The money version is simple. Everything can be clicked. This is our project. Thank you for your listening.
Here we liked the interaction and all the deep dive and the lots of custom visual, the data collection and so on. Really nice. Okay, it's time for number 2. 840 Jobs by Matt Schroeder.
It's about occupation. It's occupational data. It's compiled by the Bureau of Labor Statistics. And then all 50 states do occupation projections by state. And so it's basically a tool that's intended to help, especially younger students, kind of explore possible occupations that are out there, what they pay, and what the growth possibilities are for those jobs.
Okay, congrats.
Thanks.
You want to pick your chocolate?
You can fast forward the video, it's way too long.
Well, since you had number 2, we can actually watch it.
This is a demonstration of Wirecast.
Welcome to 840 Jobs, an occupational data visualization to inform your future. If you have questions about your future career path, then you're in the right place. This tool is designed to help you answer questions like, what jobs pay the best? Which ones are in highest demand? What are my prospects for growth and advancement in a particular career? Where am I most likely to be able to find a certain job? If you have questions like these, then this tool likely has some answers for you. But first, some background. The name 840 Jobs comes from the fact that the United States Bureau of Labor Statistics has defined 840 unique occupations, for which it gathers detailed employment and wage data. Additionally, in partnership with the BLS, all 50 states then use that information, along with state-level industry trends and staffing patterns, to develop projections of how each of these occupations will grow and how many openings they are expected to have on average each year over a 10-year time horizon. Currently, these data represent 2014 to 2024. Choose between all 50 states and DC, or the US total by using the menu at the top. With 840 Jobs, you can explore, compare, and learn about the many career opportunities that might interest you. Each circle in this cluster chart represents a different occupation. Hover over each one to see a job title.
This is a demonstration of Wirecast.
And then click to see additional information, a detailed job description, and related occupations. Each circle is colored by the typical education required, sized by the expected annual openings, and organized into 3 wage bands, low to high, within each cluster. The clusters show you how these jobs are related to one another and across various categories. Change clusters by using the menu at the top.
This is a demonstration of Wirecast.
The histograms to the right, the green bar charts, give an idea of how these occupations are distributed across the ranges of possible wages, openings, and growth. Taller green bars mean that more jobs fall within that range of the chart's axis. As you hover over each circle in the chart, information will appear on the histogram to show you exactly where that particular job falls within the distribution.
This is a demonstration of Wirecast.
Highlight portions of each histogram's range to filter the occupations displayed in the cluster chart.
This is a demonstration of Wirecast.
Below the cluster chart, you will find two maps that give some geographic context to each occupation as you click on them in the cluster chart. Click on your job of interest in the cluster chart, and the map on the bottom left will update to show which states have the least to most openings.
This is a demonstration of Wirecast.
The map on the right will update to show where that occupation is growing the fastest. Hover over each state to see the actual data.
This is a demonstration of Wirecast.
Thank you for visiting 840 Jobs, and I hope this helps to inform your career.
So I really like this one for both the insights that you can get and for the sophistication of the implementation. This could be published in a newspaper like that tomorrow. Okay, so that leaves only one, which is NBA Stats Viz by Juha, Sheng, Mengjun, Ha, and Kiwoo. You guys, like, get up.
Okay. This is simply.
Oh, congrats first. Congrats. Congrats. So you can take a chocolate each. Thanks. So you want to say something about your project?
So this is actually a simple topic. We just want to visualize the NBA player statistics. NBA player data for like fans and in general those who doesn't like basketball, and we can explore those kind of very complicated data in a very simple way.
Okay, cool. So let's take a look at the video.
This is the visualization of NBA player statistics. Once the page is loaded, you can see 4 different views. You might need to scroll down to see all of them. Here, the first view shows career summary of a player. Things on the left are basic information. The X-axis here shows the years this player has played. You can select range by brushing, and you can see update. The radar column on the right shows the player's performance index on each attribute. You can hover on them to see its meaning. You can also click on each to select, and you can see the changes. This bar indicates whether the player is better in offense or in defense. The second view shows the player's ranking. Each bar represents one season. You can see zooming by hover on bars. Star indicates the position of the current player. The red and the circle shows the actual value of this player. The third view shows the game records. It's a 2D histogram. Rows are different seasons. Rows are months and dates. You can see temporal patterns of a players. You can get data by hover on them. The plots are shown in histogram with respect to year or with respect to day and months. There are interactions between the main plots and these two charts. The last one is a shooting frequency histogram. We can use hexagon meaning to display the player's shooting frequency as well as its field goal percentage on each spot. You can get the data by hover on hexagon. There are 3 1D histograms here. The top one is the histogram on x-axis and this one is on y. You can hover to see the data by doing this. The last one is a histogram with respect to the radial distance. You can hover to see the actual region it indicates. Okay, let's go back. You can also change the player by clicking on this button and then do some queries or search player by name. For example, I want to find Westbrook and then click. Then this data is displayed. You can exit mode by clicking the button again. You can also compare 2 players with this button. Same interface again, but now if you search, for example, Michael Jordan, you can see 2 players now. Their comparisons are displayed here. You can see the data by hover on each rectangle. You can see the meaning of the attribute by hover also. Finally, you can close the comparison by clicking on the button again.
I don't think I have to say much about why we chose this as the best project. It was really like a lot of custom, awesome visuals, very well done, everything well designed, super interactive, super deep data, ability to compare, and so on. So it's really a well-deserved number 1 project. So let's give an extra round of applause for everybody. Okay, great. The rest of you will hear about your project grades pretty soon. We're pretty far ahead in grading them. So you should get feedback directly from your TA or from me, and then have the final scores entered into into Canvas. Great. So any questions about the project, about the process, before we go to a quick recap of the lecture?
So is the
This
video
is a
limit
demonstration of Wirecast.
Yes.
Oh.
It's 2 minutes. We were not very strict about enforcing it. Okay, so I kind of wanted to talk a little bit about the stuff that we generally talked about. So what I tried to do in this course is to have the 3 course components: the theory, the coding skills, and the design skills. Design, and not in terms of graphical design or sketching, but in terms of like we had design lectures, design critiques, and exercises, how to design visualization. The coding skills in terms of the labs, the deep reading, the self-study, the office hours, the hackathons, the homeworks, the projects, and so on. And the theory, of course, lecture, reading, and discussion. And so we did a lot of design critiques. So I think we did 11 or 12 design critiques or redesigns, where we really went into detail about individual visualization, and sometimes also took the time to redesign them. And so this was kind of like, as visualization is not something where we can like prove that something is better than something else, this is the way you essentially learn to evaluate visualization. So we spent a lot of time on doing these critiques and redesigns. And then, of course, I think we also taught you a little bit about programming in terms of web development, HTML5, JavaScript, and D3. I hope you found that exciting as we do. Then we started off with talking about perception, about things like change blindness, color blindness, pre-attentive processing, and so on. And we tried to relate that. How does it? Why does it matter for visualization? In which situations do you have to be aware of these perceptual properties in visualization? And then we had like these very theory-based lectures on data, marks, and channels. So we distinguished between tables, networks, fields, geometry, and then we talked about these marks and channels. And so just a note, the design critiques, many of you did really well in the design critiques in the previous midterm, but very few of you got the marks and channels right. So maybe take a look at this table again, because there's definitely going to be a design critique again, and it's definitely going to be asking again, are the marks used, what are the channels used? And then we also mentioned psychophysical power law, which is kind of the basis of arguments about why not all channels are created equal, why some are better than others. And then we had a lecture on design guidelines, where we looked at what is it that we should do in visualization, what is it that we shouldn't do. So you shouldn't do like repeated random 3D pie charts. There are alternatives to 3D pie charts, for example, like this slope chart, which was kind of similar to what you had on your previous midterm. And then we talked a little bit about embellishment and the value of embellishment. Is there, like, why would I do a graph like this compared to just a simple bar chart? Then we talked about interaction and what the value of interaction is in your visualization. Like, since we're talking about computer-based visualization, and we have the ability to dynamically brush and see relationships between views. And so we had this very like traditional video where you can simply use widgets to select ranges, and the visualization reacts to that. Or we had a parallel coordinates plot where you can select individual or brush regions, and then you see the highlights. And so this kind of like helps us resolve some of the weaknesses of visualization techniques, like in parallel coordinates, for example, that we can see the relationship of across multiple dimensions, which is hard to do if you don't interact with it. And so the rest of this lecture is about material that is kind of relevant for your midterm. And one word about the midterm, it's going to be a little bit shorter than last time. It's 5 or 6 questions, and it's not going to be terribly hard. So don't like worry too much about it. It's also not too valuable in the grand scheme of things. So just like if you understand what I was talking about and what Aaron was talking about, and if you like essentially paid attention in lecture, you shouldn't really have to study hard for that. Of course, you should review the slides, but we're not going to ask some tricky detail from one particular slide. So we talked about views. Views are important because views allow us to do a couple of things. So it's mainly about multiple views. So we want to be able to facet data into multiple views and then use linked highlighting. And so there's two different principles of how you can use these views. You can show the same data in different views, as we have here, for example. Like here we have a list of path, and here we have like a graph visualization of path. So the idea of same data, different views is that we use visual encodings that are suitable or that are complementary to each other. Or we can show different data in the different views. So here in this example, we show like one dimension from a table each, but use the same visualization. So here it's different data in same views, but also in various views. So these are the two main components of how you can define multiple views. And then you should also definitely look at small multiples and how you can partition data into multiple views. Then we talked about filtering and aggregation. So filtering is about eliminating uninteresting items and then therefore allowing people to focus on what is interesting. So we had this film finder here. Again, this is like very related to the interaction, but we define queries dynamically and then reveal the details about these items that we care about. And because we remove the clutter of the other items that we don't care about, we suddenly have more space, for example, to label the items. Grouping, we talked mainly about clustering. The slides also contain multidimensional scaling and so on, but I didn't actually talk about this in the lecture due to time, so you don't have to look into PCA and MDS for your midterm, but you definitely have to look at clustering. Clustering is important to group similar items. We talked about the k-means algorithm. Here are a couple of examples where k-means doesn't do that well. And then we talked about some statistical methods to aggregate data, such as like box plots and distribution plots, histograms, and KDEs, and so on. We had 2 lectures on tables, and so I think tables are pretty straightforward. We talked about scatterplot matrices, about parallel coordinates, about pixel-based visualization. What is important when we deal with pixel-based visualization? What is critical? If I want to use a heat map like that, what do I have to really take care of? It's the order of items in the matrix. And so that is like, otherwise this is basically useless, but if you order that, it becomes pretty interesting. And then we talked briefly, well, we had design critique and multidimensional scaling, but we didn't talk too much about this. We also talked about table-based visualization for categorical data, for example, parallel sets. This slide summarizes the major graph visualization techniques. We had explicit graph visualization techniques, load links layouts, so where each node is represented by a circle, for example, and each edge is represented by a curve that connects these circles. And so you should definitely be aware of the benefits and downsides of each of these techniques, and you should be able to reason about why one is preferable over the other. And then, so for example, you should also know why implicit layouts don't work for general graphs. Things like that. So implicit layouts were the tree map. The tree map is like a space-filling visualization that is very suitable for visualizing attributes in trees, but of course, because of its implicit nature, it doesn't work well for general graphs. And the matrix is just an adjacency matrix. Adjacency matrices are very valuable for looking at edge attributes. They are, of course, as any matrix, very dependent on your ordering, and they scale pretty well with respect to like densely connected networks. Then we talked about geospatial visualization, and I put this non-geospatial visualization on here because like whenever you think about geospatial visualization, think about, do I really need a map? Because the map has these inherent properties that make it difficult to really encode data on top of it, because I cannot like choose my position, I cannot choose my size properly if I visualize data on top of a map. So even if you have a spatial context, take care that you think about whether you really need a map, and maybe you can provide an additional visualization to better show the data. We talked about choropleth maps, so here's like a map of the election results from a couple of years ago, and then we talked also about map projections. So this is the Mercator puzzle. So you should definitely be aware of what are the benefits and or what are the criteria to think about when you think about map projections. For example, in which situation is a Mercator projection useful? When is it not so great? Could that be a problem? And so on. And then we talked about scientific visualization, or Aaron talked about scientific visualization. And so here, like roughly, you can divide the data acquisition method into scanned data and computational data. And then you should definitely have a good understanding of structured and unstructured grid. So, like if you see an example of a grid, you should have a good idea whether it's a structured grid, which kind of structured grid, or whether it's an unstructured grid. We talked about volume rendering. You should have a conceptual idea of how raycasting works. And you should have a good idea what does a transfer function do. And so what does a transfer function do? The transfer function essentially allows us to map the intensity of a volume, like of a voxel, to a color and to transparency, so that we can, for example, focus either on the bone structure of a head or on the brains. We can essentially filter based on transfer functions what we are interested in doing. For isosurfaces, you should generally know about what is the difference between direct versus indirect visualization. So direct visualization is this volume rendering with raycasting, and indirect visualization is when we extract an isosurface from a volume. And then Aaron talked in detail about the marching cube algorithm that essentially is used to define or to find out if I go through a volume on a grid, where I would have to place a triangle set so that I can actually extract an isosurface from that. Then Aaron talked about vectors, tensors, and flows. You should know about the difference, at least between streamlines and pathlines. Streamlines represent tangents, pathlines represent how, for example, a particle over time would behave. You should know about the basic techniques for flow visualization, like LIC, linear integral convolution, this texture-based method, or this direct and geometry-based method with glyphs, or these explicit lines here. And so this is kind of like the review of what you should know for your class, for midterm, and what we did in this class. I think we covered a lot of stuff, but I hope that it was also accessible. So I want to take a couple of minutes to talk about opportunities. If you found this class interesting, what else you could do. So there are a couple of seminars or advanced classes. There's the visualization seminar, which I'm also running, and together with Aaron, CS7942. That's going to be Wednesdays, noon to 1. There's usually pizza served. You can just come there and listen to the visualization research talks, or you can also sign up and do it for credit. If you do it for credit, you have to give a presentation, either about the paper or about your own work. Then there is the new, also taught by Jason, or ran by Jason, a human-centered computing seminar, CS7940. So this is going to be new next time, so if you're interested in HCI at all, you should definitely consider going to this seminar. And then there is a class next semester, CS7962, taught by my colleague Mariah Maya. This is going to be advanced research methods for visualization. It's going to be a paper-based course with readings and presentations and so on. If you're interested, take a look at the course description or write Mariah directly. If you found these projects and so on exciting, you can also think about doing an independent study, either with me or with Mariah Maya in the Visualization Design Lab. So you can go there and see the papers and the projects that we work on. And then there's two conferences that's going to be close to here. In 2017, there is the VIS conference, the Visualization Conference, which is going to be in Phoenix. So you could actually drive if you like long drives. It's going to be in October in Phoenix. It's the most exciting conference for visualization. And then the CHI conference, the biggest HCI, Human Computer Interaction conference, is going to be in Denver, also not too far, in May. There's also a data science day at the University of Utah on January the 13th. This is like essentially a showcase with panels from industry. There's a data science job fair. You can submit a poster. You could, for example, take your project from this class and submit it as a poster or as a demo. Then there's going to be a couple of data science plus X, like plus medicine talk and so on. And so if you want to learn more and participate, you can go to this URL. Okay, so then I kind of wanted to open up the floor a bit for feedback. I've run this class a couple of times now, but I still would be interested to hear from you guys now, like informally. You can say whatever you want. I won't take it personally. Were your expectations met? What else would you have liked to learn about? Did you feel prepared for this class? Are the prerequisites appropriate? Was it too much work? Was it too easy? Was it too little programming? Too much programming? Did you like JavaScript? Did you like D3? Did you enjoy the project? Would you rather get rid of the project and do more homeworks? Would you rather not do like web-based development and so on? So like, please feel free to comment on any of those points.
Wirecast.
Was this the first time that Aaron came in and did lectures?
The second time.
Okay. I felt like it was very, very, very different from the entire rest of the semester, and it was just kind of a little bit too much, kind of thrown at you in 4 lectures.
Yeah, so thank you. We're actually thinking about splitting this class in 2 and doing an InfoVis class and a scientific visualization class in the future. That's not set in stone yet, but it's a problem that we have because there's just so much to cover. And me personally, I'm more interested in the first part of the lecture, and therefore I'm probably treating the scientific visualization aspect not as detailed as it should be. So I think this is a point that is very, well, true.
This goes along with that, but if you don't split them, there's a lot of scientific viz that he went over as though where high level understanding was good enough, and I ended up not knowing what he was talking about because it was on something really specific. And so there were certain things that were high level that he went over high level, should have been low level, and then other side too, there were some things that were easy low level that he spent a long time talking about.
Okay. Opinions about the project?
This isn't directly from the project. I thought that design experience and being graded on it was good, but I'd like more of
This is a demonstration of
having other homeworks
Wirecast.
to get us going on the programming skills was great, but I think I would get more out of the class having several design your own visualization, probably not as much not as labor intensive with less documentation, but build more different kinds of visualizations.
So you're saying that we should also take the opportunity in homework to give you more liberty on how to implement something and give you more qualitative feedback on your choices? Or is it?
Either that or split the project up and rather than here's one big project, do 2 or 3 little ones.
Okay.
I'm glad we had the project instead of the homework. Sometimes the homeworks were a little, like, they were a lot. At least, I don't know, once again, I'm from a group of people who are nuclear engineers with 0 computer science background, so maybe it wasn't as difficult for some other students to pick some of this coding up. But I like that the project, we were able to have that liberty to do
of
what we wanted.
Wirecast.
Sometimes it was difficult to hone in on like a very specific visualization when they got pretty tricky. I mean, I realized we needed those in order to have the foundation to make our own project, but I definitely wouldn't say to do more homeworks. I think having the project at the end.
So more, but maybe smaller homeworks?
Yeah, that would be nice.
Yeah.
I think coming from outside of the computer science department, it would be useful for, if you guys end up splitting the course, I think the scientific viz was definitely more what we were looking at getting out of the course. So that would be good from an external perspective. And also, if it's a scientific viz course where you're trying to bring in people from other departments, then maybe instead of building the codes at the beginning, giving out codes for students to play around with and figure out how the pieces are working, and then developing their own final project, so that the emphasis is more on them building a scientific visualization than
This is
you know,
a
learning
demonstration of
Okay.
Wirecast.
Any other opinions or other points?
It'd be nice to do a scientific computing project, or, you know, if there's a homework related.
Scientific visualization project?
Yes, scientific project.
Yeah, so we had this last year, and the problem with that is that it's hard for scheduling. Like it's hard to do homeworks about topics that you didn't cover in class. And last year we didn't cover maps and tables until the very end, for example, and graphs. And I felt this was kind of not so great. This year I felt the same about the scientific visualization. So it is tricky, but I definitely see the point that we should have homework on scientific visualization.
Yeah, it just, for me, it helps to have practice using something, whatever it is, whether it's scientific, whatever's in the class, practicing with it is just.
Yes.
So also I appreciate that you guys are so current with the technologies that you use. I feel like it can be hard to keep pace with like web stuff. But there's a lot of courses here
This is a demonstration of
I know
Wirecast.
like the web dev course here is like PhD, which I think is kind of sad. Just because like that's what it's been for several years. I'm glad you guys use like companies a while right now are using D3. It's like great technology. So I appreciate that.
Thanks. Did you feel like prepared from a technical perspective, or just like this front loading of this is how D3 works? Was that useful?
On that note, if anything, I would have wanted more lectures on
This
coding,
is
or
a
maybe not
demonstration of Wirecast.
lectures. I think what helped me the most, I thought Carolina was an angel with all of her extended office hours, and I would have died if it weren't for her. And so that's one thing that I really did appreciate was I felt like, really put in, I mean, there were lots of office hours, but I think she made sure to make more office hours to meet that need. And I think sometimes office hours occurred at a time when the students hadn't really started the homework
This is a
yet.
demonstration of Wirecast.
Generally starts the homework that early. Or it was just, I thought it was great that she would extend it, but I could tell it was like really overwhelming for her since she was the only one. So maybe even having a concentrated office hour towards the deadline, just being realistic, knowing most students aren't going to start it a week and a half in advance, but knowing that most of them will start towards the end if more office hours were open at that time, unless Carolina just likes taking on 30 students at once. But, so I did really appreciate that, but I thought maybe
of
with
Wirecast.
office hours it'd be more beneficial to have that scheduled out so that it wasn't so stressful and just felt good.
So can I have a raise of hands who thought that we started too slow with HTML and JavaScript? Too slow, like too easy the first 2 or 3 lectures. Okay. Who thinks we didn't cover this in enough detail, or should have spent more time on the technical aspects? Okay, thanks.
This is a demonstration
Workload.
of Wirecast.
Was it too much? Yes. Really? Just a little. Well, okay. Well, it's always tricky to find a balance, but yeah.
I think the workload was more of an issue at the beginning of the semester because you front-loaded all of those homeworks where we were learning all of the skills. So if you weren't already up to speed, you were spending a lot of time catching up. And I think one of the ways that I really felt we could have cut down on that front-loading is if it had been sort of like I said earlier, here's a data visualization with certain implementations. Now I want you to go change it so it looks like this, and then you're not building the code, but you're playing with it. So you are learning the techniques, but the syntax isn't going to be as big of an issue at the beginning of the semester.
So I kind of like the projects that we did, but in terms of workload, I think the initial project, like final project proposal and writing,
demonstration of
could
Wirecast.
have been done in parallel with our homeworks, and in return we could have had more time on each individual homework rather than just like doing nothing and doing writing.
Any other comments on workload?
I feel the homework, especially the last 2 homework, are very difficult for me because I'm not from a CS department, and I feel it's really, really difficult for me to finish that. And also,
This is a demonstration of Wirecast.
The D3 and JavaScript for majorly the program for the visualization, but I hope that you could also include some Python visualization or R or other major language, because I'm from business school. I never touched the JavaScript before, and I think maybe I have no chance to touch that in the future.
So would you rather that we do Python as an alternative or in addition, or as an alternative or in addition to JavaScript? Yeah, so I did it once, and it just was for people who didn't, like, they had to learn 2 languages suddenly. And I totally see the point, and I think it's really important to be able to web scrape and acquire data. And this might be something that if we, for example, make this a proper, like, only InfoVis course, we might take more time to do that.
This is a demonstration
it's
of
not
Wirecast.
easy to do. So some other comments? Yep.
Maybe you could allow submitting in either or language.
Well, the problem is that, at least in Python, you can't really do interactive visualizations. There is like a lot of statistical graphs, and I teach Python statistical graphs and machine learning stuff and so on in my data science course, but there is like very little that you can do in terms of creative, interactive visualization. So we could think about allowing, like, making it language agnostic and allowing people to do Java, processing, Canvas, or whatever. But then I can't really teach D3 in the lectures. So yeah, that's the...
I was just gonna say, for the workload, like, I feel like I already knew the programming stuff really well, except for D3. And even knowing that really well beforehand, the homeworks were still a lot of work. Like, it took like an entire day or 2 entire days to get it all done.
Yeah. So would you have like more atomic homework with like one view here, one view there? Would we try to make a mini project that was useful in itself, but...
Yeah, I don't know. I'm not really saying that that's bad or good. I'm just telling you that's what my experience was.
Yes. Okay.
I liked the projects, and I feel like I learned a really good skill in this class.
Yeah. Great. So like...
Just kind of adding on, I think something that might help that is if, instead of having like a week and a half, 2 weeks to do a project with multiple views, trying to coordinate like specific steps of that main project.
This is a demonstration of Wirecast.
So maybe 1 or 1.5 assignments due over the course of a week or something like that.
Yeah.
Like a really small building blocks that you put together at the end.
Yeah. Great.
This goes back to D3 a little bit, and when we talked about it in class, I felt like I got a good idea of what the language was trying to accomplish, but I didn't think the documentation was very helpful for finding specific commands, and probably 25 to 30% of my homework time was just trying to figure out D3 syntax. And so, that syntax, I made something to look at examples, understanding looking out there, but a lot of it was, well, I know there's got to be a command that does this, and I just had no idea what that command is, and there's nothing that helps me find it. And so if you gave like a bank of, these are commands that will probably be helpful in this homework, it would save a lot of time.
Okay, yeah, that's a great comment.
I think another problem with that, just because version 4 is so new, there isn't a whole lot of resource out for it yet.
That's true. Like, it was brand new.
It probably won't be an issue next year.
It was brand new, and we kind of like were going back and forth whether we should switch. We decided to switch to version 4, but not to ECMAScript 6. And so next semester we'll teach ECMAScript 6.
I think one thing about the homeworks that was helpful though was seeing the underlying code when you guys passed out finally the solutions, seeing the underlying code for the different types of views. And I think that it might be helpful also if you guys have a chance to include more examples so we can see even more possibilities than just the ones that we saw in the homeworks.
Yeah.
So kind of like D3 gallery.
This is a demonstration of Wirecast.
I think this is going to be easier in the future when there's more blocks for D3 version 4. It is like, there's not major differences, but there is enough that it won't work if you paste it. Okay, so I want to skip one slide and go back to it. First, I want to thank especially like the TAs. wouldn't have been possible without you guys. You did a great job preparing homeworks, helping with the grading, and office hours, and like even hackathons and labs and so on. Another thanks to Aaron and Janet for guest lectures. And then thank you guys for coming, participating in lectures. And now I would like you to also please do the course evaluation. I put up the link here. You can do it right now. Please take 5 minutes to evaluate this course. The evaluations are important. Like, it's important for us to get your informed feedback, but we also need this formal feedback to improve the teaching, to improve the course, and to see how it should develop. So leave any comments. Don't hold back. Say this didn't work out well. Say this was a problem. Make positive suggestions on how this is how you could change that. And I would appreciate if you take 5 minutes now to evaluate this course. And then we'll see each other on Thursday for the midterm. And thank you guys for participating in this class.
Are we doing project presentations?
No, that was just the leftover.
That's slides.
Yeah, that was leftover from another class. Or I recycled the slides.